In this problem, we're trying to solve an IVP, a second order differential equation with some initial conditions, y double prime plus y prime plus 5/4 of y equals f of t, which is a step function, sine of t0. This is for t between 0 and pi and t greater than pi. Under the initial conditions, y of 0 equal 1 and y prime of 0 equals 0. So this is the IVP. Again, because the function here is a step function, then we are going to be using Laplace, and using the formula for Laplace of y double prime, we get Laplace of y double prime plus Laplace of y prime plus 5/4 Laplace of y equal Laplace of f of t. So let us go first to y double prime, that is s squared Laplace of y minus s y of 0 minus y prime of 0. And then what's Laplace of y prime? That's s Laplace of y minus y of 0 plus 5/4 Laplace of y. And this should be equal to Laplace of f of t. So let us put together the terms that have Laplace of y. So this will give me s squared plus s plus 5/4 Laplace of y. And then we have y of 0, which is 1. So this term and this term will give me minus s minus 1, because y of 0 is 1. And finally, this term here is equal to 0, because y prime of 0 is 0. All this gives me Laplace of f of t. Therefore, s squared plus s plus s plus 5/4 Laplace of y. We move minus s minus 1 to the other side, and this will give me Laplace of f of t. And finally, Laplace of y equal s plus 1 over s squared plus s plus 5/4 plus 1 over s squared plus s plus 5/4 Laplace of f of t. And now we need to find f of t. For that, we're going to use the UC's function. So recall that the UC is the function that's equal to 1 after c and 0 before. And this sometimes is also denoted by hc of t for his side, okay? So it depends on the authors. I'm going to be using UC anyway. So we know that f of t is equal to sine of t times u pi of t. So the Laplace of f of t using the table of Laplace, e minus s pi Laplace of the sign shifted, and sine of t plus pi, that's minus sine of t, and therefore we can put the minus outside, minus e minus s pi Laplace of sine of t. And using again the table, we know that's going to be 1 over s squared plus 1. So putting the stuff together, we find that Laplace of y is equal to s plus 1 over s squared plus s plus 5/4 plus 1 over s squared plus s plus 5/4 minus e minus pi s over s squared plus 1. And when the dust settles down, using only algebra, we find that this is s squared plus 5/4 minus e minus pi s time 1 over s squared plus 5/4 time s squared plus 1. So, what we're going to do in 2 times. Number 1, we're going to try to find the Laplace of this one. And then we're going to find the Laplace of this one. So let's do it step by step, okay? So the first one, the inverse Laplace of the red one. So here, we're looking at s plus 1 over s squared plus s plus 5/4. We need to do the partial decomposition technique, and therefore we need to look at the bottom, and we find that the bottom has complex values, and therefore what we're going to do is complete the square. So if we complete the square, we'll find s plus 1 over s plus 1/2 squared plus 1. So in order for us to use the sine and cosine, I need s plus 1, so 1/2. So I get s plus 1/2 plus 1/2 over s plus 1/2 squared plus 1. And now we divide. So this gives me s plus 1/2 over s plus 1/2 squared plus 1 plus 1/2 over s plus 1/2 squared plus 1. So 1 it is, again from the table, the Laplace of e minus 1/2 t cosine of t, while this one is 1/2 Laplace of e minus 1/2 t sine of t. Putting the stuff together, it gives me e minus 1/2 t cosine of t plus 1/2 e minus 1/2 t sine of t. So this gives me the red one, okay? And now I go to the blue one. For the blue one, what we are going to do, so we have e minus pi s time 1 over s squared plus s plus 5/4 time s squared plus 1. So what we're going to do, we're going to ignore this term for a second, find the inverse Laplace of this term, and then use the shift formula with the UCs, okay? So let us focus on s squared plus s plus 5/4 times s squared plus 1. So this will give me, using the partial decomposition technique, as plus b over s squared plus s plus 5/4 plus cs plus d over s squared plus 1. Okay? So here I'm going to go and not do the details of the algebra to find a, b, c, d. I'll leave it to the listener to do that. Okay? Just pure algebra. So this is 16 over 17 times 4s plus 3 over s squared plus s plus 5/4, and then minus 4 over 17 times 4s minus 1 over s squared plus 1. Okay, so now I need one piece it's easy to handle is the second one, the one that we have there for s minus 1 over s squared plus 1. But let's focus on the one here with, so this is 16 over 17, 4s plus 3 over, again complete the square, plus 1 minus 4 over 17 times 4s plus minus 1 over s squared plus 1. So this gives me 16 over 17 time, and now I need, in order to use the shift formula, the one that we used before, I need, instead of s, I need to have s plus 1/2. So for that, we're going to do 4 times s plus 1/2 minus 1/2 plus 3. This is the trick. If you need a term that you don't have plus a term, you just do plus minus. 4s minus 1, s squared plus 1 here. So again, continuing with the algebra, I will get equal